Hello viewers, this is Peter Ekaja from St. Joseph's Vocational School, going to take you through matrices. Remember, I have a YouTube channel and it is called eMath Learning Platform, where I upload most of my videos for the tutorials, especially in mathematics. So always feel free to subscribe to eMath Learning Platform for continuous updates. Subscription is actually free of charge, and when you subscribe you will always be updated the moment I upload new content on my YouTube channel. Now for today we are going to look at matrices, and the subtopic is going to be inverse of a matrix. Before we go deep into that, I said my YouTube channel is still eMath Learning Platform, and the contacts below belong to me, with the second one being on WhatsApp for any kind of clarifications or questions that you may ask. Let's look at an inverse of a function of a matrix. Now we are going to consider a 2 by 2 matrix, for example ACBD. The inverse of this matrix A can be denoted by A power negative 1. Now A power negative 1 is pronounced as A inverse, and it is given by the formula below. So A inverse is equals to 1 out of the determinant. This one represents determinant of A times the adjoint of A. How do we get the determinant? The determinant is obtained by multiplying the elements in the major diagonal. Then you subtract the product of the elements in the minor diagonal. So you realize shall have A times D, which is AD, minus C times B, which is CB. So that gives you the determinant of your matrix A. Then we can look at how to get the adjoint of that very matrix. Now for the adjoint, it is quite easier. The concept is look at the major diagonal, exchange the positions of the elements. So it means the position of A will be taken up by D, and the position of D will be taken up by A. That is why you see I have D here and I have A here. I've just exchanged the positions of the elements. Then on the minor diagonal, which is this one here, what you do is you just change the signs of the elements. So that is why B was a positive, now it has become a negative, and C was a negative, sorry, a positive, and now it has become a negative. So it means if this was a negative originally, then it would be a positive here. So the issue is, or the concept is, you have to change the signs of the elements in the minor diagonal, but you exchange the positions of the elements in a major diagonal, the one I'm trying to point out for you here. So if you have all this, then you just do the substitution in this formula and you will be able to get the inverse of your matrix. Now remember, at our level, especially ordinary level, we shall always strictly look at a 2 by 2 matrix in case we want to find the inverse. Now let's look at some few examples. Number 1 says find the inverse of the matrix, part A. Part A, they gave us 2, 3, 5, 6, 4, negative 2, 3, 5, negative 5, negative 1, 3, 3. Let's look at the solutions for that. Part A. Now when you look at part A, we are going to basically follow the concepts we have discussed in the previous stage. So we are going to look at this matrix, and if we are to find its determinant, because we said inverse is equals to 1 out of determinant times the adjoint. So the first step is find the determinant. The determinant will be 2 by 6 in the major diagonal, which is this, minus 3 by 5 in the minor diagonal, which is this. So you come up with 12 minus 15, which gives you negative 3. Next step is to find the adjoint. Adjoint, we have just said, simply exchange the positions of the elements in the major diagonal, then change the signs of the elements in the minor diagonal. So that is how this adjoint was obtained. Then finally we bring our formula for the inverse. We said inverse is 1 out of determinant times the adjoint. What are you going to do there? You simply substitute your information. Remember, we got the determinant as -3 and we got the adjoint matrix as this. So we have just substituted, so it is 1 out of -3 multiplied by this adjoint here. Now 1 out of -3 is as good as -1 out of 3. A negative is mathematically allowed to move to the numerator. And so the concept here is you're going to multiply each of these elements by -1/3. So it will be 6 by -1/3, -3 by -1/3, -5 by -1/3, and 2 by -1/3. Should you do so, you will surely come up with your inverse as this. Because -1/3 times 6 gives you -2. -5 times -1/3 will give you 5 out of 3. And -1/3 times 3 gives you +1. Then -1/3 times 2 gives you -2 out of 3. So that is simply the concept. Very, very interesting. So let's move to part B and we look at this other example. So part B is still going to be done using the same principle or concept. Find the determinant by getting the product of 4 and 6 in the major diagonal. Subtract the product of -2 and 3 in the minor diagonal. Should you do so, you will have 20 here, and this will give us -6. So it is 20 minus -6, which is +26. Because a negative and a negative will always give us a positive. Get your adjoint. Exchange the elements in the major diagonal. So I have 5 going to the position of 4 and 4 going to the position of 5. Then change the signs of this. Now remember, here we have a -2. So it means the sign here will change from -2 to +2. And here, since we had a positive, it now changes to a negative. Then finally, our formula comes in, like we had discussed earlier, and you do the substitution. So it's going to be 1 out of 26 multiplied by our adjoint. Then again, 1 out of 26 will multiply each of these elements, and that will simply give you such a kind of matrix, and that will be our inverse of the above matrix. I hope you're getting the concept clearly, because I have tried to stipulate all the steps very, very clearly and precisely. Let's look at part C. Now in part C, still the concept is still the same. Get the determinant, -5 by 3 in the major diagonal minus -1 by 3 in the minor diagonal. This will be -15, and this will be -3. And a negative will give us this positive here. So -15 plus 3 will give us -12. Next step, get the adjoint. Adjoint, exchange the positions of the elements in the major diagonal and just change the signs of the elements in the minor diagonal. That is basically what I have done. Then finally, go substitute in the formula of inverse, which is given by 1 out of determinant times the adjoint. Then finally we shall have this, and again 1 out of -12 is as good as -1 out of 12. So -1 out of 12 will simply multiply each of these elements, and as you try to simplify where necessary, you will get -1/4, -1 out of 12, +1/4, and 5 out of 12 as our inverse. Interesting. Let's look at the next question, number 2. Number 2 is quite very interesting, and people like checking on students to see whether they really got the concept clearly. They're saying, given that a matrix A inverse equals to 2, 4, 4, 6, find a matrix A. Now this time they have given you the inverse already, and they want to get the original matrix. What do you think we can do here? Simply, you need to just reason it out easily. That if they've given me the inverse of the matrix and they want me to get the original matrix, I simply get the inverse of this inverse matrix. What do I mean by that? Let's look at the solution. So I am saying here that A is equals to A inverse but inverse. When you say A inverse but inverse, you realize that -1 multiplies -1 to give you 1, which is still the same as A. A power 1 is the same as 1 if you go back to the idea of indices. But let's come back to matrices now. So what does it mean? it means we are simply going to get the inverse of this matrix normally, and the steps and procedures will be the same as in the previous questions we have just attempted. Get the determinant of A inverse, giving us 2 by 6 minus 4 by 4, and that will give you 12 minus 16, which is negative 4. Get the adjoint of A inverse again. Now we are focusing on A inverse because it is what is given to us. So we have got all that. After, apply your formula. Now matrix A will give us, because remember now matrix A is the inverse of the inverse of this matrix. I come again. I'm saying matrix A will be the inverse of this inverse matrix. So the formula will be 1 out of the determinant of A inverse times the adjoint of A inverse. Simply substitute your information and you will come up with the negative a quarter into 6 negative 4 negative 4 2, and when you multiply each of the elements by negative a quarter, you will surely come up with this result, and this will be your original matrix A. So what have you understood here? I expect you to take it easily and simply that when I'm given an inverse matrix and I'm asked to find the original matrix, I simply get the inverse of the inverse matrix. Full stop. Simple and very clear. Now, from what you've studied, I now expect you to try and attempt this exercise to prove whether you really conceptualized or understood all that we have explained in the previous stages. And make sure when you're playing this video, you always pause in case you want to write down something, because if it is playing at a high pace, you may not be able to capture all the information. So play and pause as you extract the information you need. Number 1, find the inverse of each of the following matrices. Part A is given by this, part B is that, and part C is that. Part D is that, part E, part F is that. And finally, number 2, find the matrix F for which. Now I'm giving you the inverse matrices. So this number 2 will be attempted based on the idea of number 2, and number 1 will be attempted based on the ideas of example number 1. Thank you very much for listening. Thank you for being very good listeners. May God bless you. Have the best of your day, and always remember to visit YouTube and subscribe on my channel Math Learning Platform for you to receive updates each and every time I upload new content on that platform. Have the best of your time. Bye bye.